The first mechanism in the Rube Goldberg machine references units of study such as nuclear energy, sound, and energy in society. Unfortunately, the trial provided the engine car was malfunctioning and didn't work, so as a result I had to push it. But to explain, it involves the transformation of potential chemical energy from the kerosene and oxygen through combustion. Then it is turned into thermal energy, which is the fire. Through the mechanisms in which the piston is turned from the increase in pressure as gas is heated, the thermokinetic energy is transformed into mechanical energy that results in acceleration, therefore increasing the kinetic energy. Specifically looking at the relation of nuclear energy, we have to divert our focus to the fire alarm. This alarm was placed above the cart in order to signal the person down the hill to activate the solenoid. I'll elaborate on this later. Americanium-241 is an alpha-emitting isotope, and it's used in smoke detectors. As it sheds particles, it interacts with neutral air particles within the chamber. Ionizing these particles, electrons break apart and attach to other air particles, forming positive and negative ions. The two electrode plates on either side of the chamber attract the particle of the opposite charge, creating a small current. When exposed to smoke, the smoke particles interrupt the contact between these two particles, alpha and air, resulting in a reduction in current that triggers the alarm. This is applicable to our nuclear energy unit because understanding the behaviors of alpha, beta, gamma, and other particles is necessary for the application of concepts such as dosimetry, background radiation, fission, fusion, or even criticality in nuclear bombs. Unfortunately, in my Rube Goldberg machine, there are no objects breaking the sound barrier, so that sound application is unavailable. However, with an alarm designed to inflict auditory pain, we can determine how far it is away from the resonance frequency of our ears. Research shows that the average fundamental frequency of our ears is 1.2 kHz. Additionally, about 165 decibels or more can rupture our eardrums. Sounds such as close gunshots, explosions, or extremely loud music are examples of frequencies that are close to 1.2 kHz or about 165 decibels or more. A fire alarm exerts a frequency of about 3 kHz, normally between 60 to 100 decibels. This compared to the fundamental frequency of human ears in the decibel threshold shows that fire alarms can't immediately cause damage to the ear. However, with prolonged exposure and within a close proximity, it can cause auditory damage. This mechanism involves the force of tension, which releases the weight attached to a pendulum. This is a simple pendulum. It has a point of mass called the pendulum bob, suspended by a string. Forces acting on the bob are gravity and tension from the string. And the period of a pendulum is the time it takes to make one full back and forth swing. Another interesting fact is linear displacement from equilibrium, which is the resting point, is considered the arc length. The pendulum swings across and releases the weighted carton. The coiled weighted carton stores a high amount of potential energy. When it's released by the pendulum, due to the force applied at a precise point of contact, it begins to unwind. The carton graduates out on a wider radius. This is an example of angular momentum, where the law of conservation of angular momentum applies. Assume there is no external torque acting on the carton as it spins around the pole. There would be no change in angular momentum, therefore it is conserved. This mechanism is simply a spring-powered rat trap with a high potential energy. It pulls on the rope when it's triggered, and in turn pulls on the trigger that keeps the rake from rolling down the hill. In this situation, where the rake is rolling down the picnic table, it has a high rotational velocity and begins to accelerate and eventually hits the basketball off of its balancing point. In this system, I'm assuming that the maximum height is 25 meters. Since the ball does not go all the way down the hill, I will assume that it ends at 10 meters. Here is an example mechanical energy equation used to simulate this process. It turns out, through the relationships of kinetic and potential energy, and my former knowledge of energy in society, the final velocity is 13 meters per second. I do not believe that these results are completely accurate to the situation. However, it is just an example. This final system specifically relates to the units of electricity and electromagnetism, as a circuit that I built involves the use of a solenoid or electromagnet attached to a car battery. I found these parts at an auto wrecker. However, I ran into a few problems during the process. After a few minutes with the solenoid activated, it would start to overheat. This connects back to the first mechanism, where the smoke detector would signal myself or the individual down course to activate the circuit in order to minimize time and avoid overheating. This final system is simply just the passage of water through pipes to get to the plant, but the green bucket, called a whiz-bang, is used to control the flow of water. At the end of the whiz-bang, there is a small tightening screw where I can tighten or loosen to control how fast the water is flowing out. This means that I can water the plant over a longer period of time at a slower pace.